Hello, hello, hello. Today is Sunday, June 25, 2023. Problem 174, which deals with the physics of the Titan submersible. You see here a picture of the submersible. It has no drop mass attached. This is just the submersible alone. You will see this picture on every newspaper. The dimension of Titan, which is from here to there, is 6.7 meters, and then the cross section in this direction is 2.5 meters by 2.8 meters. Now, to calculate its volume, I have taken as its length only 70% of this distance, because clearly the cross-section here is not this large. So, somewhat arbitrarily, I have multiplied this volume by 0.7. And so I find then that the volume is 32.8 cubic meters, call it 33 cubic meters. So the buoyancy force is the weight of the displaced water, which is then about 33,000 kilograms. Notice that I will use kilograms for both force and mass. That is completely reasonable. I realize that mass is not force and force is not mass. That is irrelevant. In fact, in high school, we learned about kilogram forces. That's no longer done. Okay, I used force and mass, kilograms, same way. The weight of Titan alone, without the drop ballast, is 6,000 kilograms. So notice, it's a weight, and I use the word kilogram, which is perfectly fine. The drop mass must therefore be larger than 23,000 kilograms, because the upward force is 33,000 kilograms. And so in order to go down all by itself, you must have a balanced drop mass. I call it ballast because later you will drop it. Because the drop mass must be larger than 23,000 kilograms. Let's assume the drop mass was 25,000 kilograms. It may have been larger, but let's assume that. 25,000 kilograms of lead has a volume of about 2.2 cubic meters. Now take the length of a lead rod and make that length 2 meters. The rod's cross-section is then 1.2 square meters. In other words, it would be a lead rod 2 meters long with a radius, cross-sectional radius of 60 centimeters. That's big. Where is the drop mass located? That's my first question. How is it attached to Titan? I have not seen any picture of Titan with the drop mass attached. Pretty silly in my book, but I have not seen such a picture. Titan free fell to the ocean floor. Its speed was what we call the terminal speed, which is obtained when the upwards frictional force due to its motion downward through water equals 35,000 kilograms. Again, I use kilograms for both force and mass. The question 2 is now, what was the terminal speed on the way down? Assume for simplicity that Titan and the drop mass had made it successfully to the ocean floor close to the Titanic. What then would have been the upward force needed to pull Titan plus the drop mass up using a 4-kilometer long cable? I want to remind you that the depth of the Titanic is about 3.8 kilometers. The reason why I want you to calculate this is that what newspapers mentioned is utter nonsense. You can do better. Okay? Simple high school problem. It has intrigued me ever since the accident happened. I hope you can put some physics in there and help me understand what I don't. Notice that the mass, or weight, if you want to call it that way, of Titan is 10,000 kilograms. I mentioned 6, but my writing is correct. It's 10,000 kilograms.